All right, so for today, we are going to be looking at finishing up just the rest of our notes here for Concept 3. So we ended here yesterday or the day before on vaporization, evaporation, and boiling, and how both of those two are basically the same thing, so it can occur two different ways. So the last thing that I want to touch on is this graph here that talks about heating curves. And so when we look at a graph, we always want to identify, what's on our x-axis and what's on our y-axis. So on our x-axis down here, we can see heat absorbed. So basically, this just means that the temperature, that you're absorbing more heat as you go on down the, towards this way here. And then over on the y-axis, we have temperature in degrees Celsius, all right? And so we can see that as heat is absorbed, the temperature increases. All right, so that's something to make a note of. As heat is absorbed, temperature increases. So as heat goes up, temperature goes up. But then you get these points where nothing happens, but heat is still being absorbed, but you still don't have a temperature change. And then all of a sudden it goes back up again. As heat is absorbed, so does the temperature. And then again, you hit a point where you are kind of stagnant, but you're still absorbing heat, but no temperature change. And then eventually you can keep going back up. So a heating curve is a diagram that shows the state transitions a substance goes through as heat or energy is added to it. So a diagram that shows the state of transitions, that's a key word here, that substances go through as heat or energy is being added. So another way we can look at this is on the bottom there, instead of heat absorbed, we can also look at it as saying heat added. All right, so now we're going to identify a couple different parts of this curve here that we see. So from anywhere in degrees Celsius, from below 0 degrees is going to be a solid. Now remember, in this case, this is just water right up here. I don't know if I made that clear. This is just water. So water is a solid up until 0 degrees. Then as heat continues to be absorbed, remember when heat is absorbed, its kinetic energy is increasing. So in this solid, the molecules are starting to move a little bit more. And at some point right here at 0 degrees, then the kinetic energy of those molecules begins to shift from a solid form to a liquid form. And so this is the phase of melting that happens right here. So as more heat is absorbed, we can continue to go up in temperature. So anywhere from 0 degrees Celsius to 100 degrees Celsius is going to be a liquid. And again, these temperatures in Fahrenheit would be 32 and 212. Whoops. So between these two temperatures, we have a liquid. Now, as you absorb more and more heat, once you get up to 100, though, then we have another shift. So at this point, we have boiling. Remember, we also call this vaporization. And then after this point, it is no longer a liquid, it turns into a gas. All right. So the length of these lines, these flat lines here, does not really matter. It does represent kind of a stagnant point where, at 212 or 100 degrees Celsius that it's just taking time to absorb that heat. But then once it goes up and over that, it'll turn into a gas. Okay, so that finishes up the notes for Concept 3. What you're going to be working on is I want you to do the summary for concept 3 right here. So provide reasoning for why state change is physical and not chemical. All right, so I want you to tell me, why is the state of change a physical change and not a chemical change? Go back to your definitions for those to sum that up. Okay. After that, I want you to work on the last page of the packet here, which is page 29. So answer questions 1 through 5, and that's what and then go ahead and submit pages 28 and 29 to Shobi. All right, that's it. Thank you.